Welcome to the practical calculations of your quantitative techniques. What we're going to do is to look at this question. So here it goes. It reads, a shopping mall needs to calculate some stats regarding the shopping patterns of their patrons. They collected the following data in order to assist them with their research. Having read the question, the requirements would be for you to draw a table. The table might not have much, but it will assist you in order to be able to do your calculations properly, because quite a lot of questions are based on this. So you would need to extend the table and put some columns in there. So I'm going to extend the table, put the columns, and then we see together. The first part was to put the class interval, which is the number of minutes that the shopper spent. We were told of the frequency or the count, how many times we see this occurring. So between 0 to 10 there is 3, so I'm gonna put the 3 here, and the frequencies as they are given there. The last one is 4. So this is your F, your frequency. For the calculation of the mean, you actually need to have the midpoint. The midpoint is kind of like your X bar. It is the number that would be representative of these class intervals. And then after that you would need to get the frequency multiplied with the midpoint, and then get the frequency multiplied with X that is to be squared, and then you would need to show the cumulative frequency. Now the cumulative frequency is a continual adding of the numbers. I would prefer to show it at the very end so that you don't confuse yourself. So you need a calculator, and now we need to calculate the midpoint. How do we calculate the midpoint? The midpoint is essentially calculated by saying midpoint is equals to half the class width plus the lower limit. So in essence we have to know, in terms of the class intervals, what is our upper limit and what is our lower limit. So this is your lower limit, all the figures to the left, and this is your upper limit. You don't need to write this, you just need to know where to find it. So what is the class width? The class width is the gap, and the gap is going to be the same for all class intervals. So the gap between 50 to a 60 is actually 10. The gap between 40 to a 50 is a 10. The gap between any of these numbers is a 10. So we're going to say half of 10 plus the lower limit. So we are saying 5 plus the lower limit is going to be our midpoint. Some people find it easy to say 0 plus 10 divided by 2. That will be a number that represents the midway between those two numbers. But I'm just going to say half the class width plus the lower limit. So this is going to be 5 plus 0, that's a 5. 5 plus 10, that's 15. This is 25, this is 35, this is going to be a 45, this is going to be a 55. We now need to multiply the frequency times the midpoint, so it'll be easier to do this whole calculation coming to here, because here we multiply 3 multiplied by 5. We put the 15 here, and then here we are saying 3, which is the frequency, multiplied by x squared. Our x is 5, so we're going to square the 5. So that will give us 75. So let's do the calculation. 3 multiplied by 5 is 15. And then we play back, we square the 5, that gives us 75. And then we come here, 7 multiplied by 15 is going to be 105. And then we play back, we square the 15. If you are effective with your calculator, you're going to save yourself a lot of time doing these calculations. 225, play back, square this, we get 5625, and then this is 8 multiplied by 35, which is 280, and then we come back, we play back, this is 9800, and then we get to 5 by 45, which is 225, play back, square the 45, we get 10,125, and then we play back, we go to the 4, multiply by 55, 220, play back, square this, that's 12,100. Now make sure that your table is absolutely correct, because if this table is wrong, we're gonna have a problem. So I need the totals. I'm going to create space for my totals just at the bottom here. Right, so we need to calculate the totals. First do a checkpoint. So we need the summation of fx. This is what we're gonna get here. We need the summation of fx squared. By summation, we're simply saying add up these things and find the total and put it here. You just need to check as well whether you've accounted for all the numbers, but you can also check using the cumulative frequency, because when we calculate the cumulative frequency, we're going to say 3 plus, there's nothing before the 3, so this one is a 3, 3 plus 7, that would be a 10, 10 plus 9, that's a 19, 19 plus 8, that's a 27, 27 plus 5, that's a 32, 32 plus 4, that's a 36. So you're supposed to have your 36 observations. Once you have your 36 observations, you're ready to add up. So let's add up 15 plus 105 plus 225 plus 280 plus 225 plus 220. This is 1070. And then we do the summation of the fx squared. 75 plus, we are adding all these numbers going down, we give you 39,300. So that's the total there. We need this table for we're going to do the mean and everything. We're going to calculate using this. For easiness, we're just going to use the side space to do the calculations. I think it's going to make our calculations a little simpler. So we're going to start first with the requirement A, which is to calculate the mean. So A, calculate the mean. The mean is the average, and for us to calculate the mean, we need to take the formula. X bar is equals to summation of fx over n. This is the grouped formula because this is group data. So we're going to substitute. What is the summation of fx? Summation of fx is 1070, and we're going to divide this by the total, which is 36. So our average, 0 divided by 36, would be equals to your 29.72. These are minutes, of course. Minutes. That's your average. That's your A. So having done the A, we would move to B. The median, I'm just gonna work it out here. Just gonna make a bit of space. So the median is the middle number when the numbers are arranged in ascending order. Okay, this is a table. It is arranged in ascending order, but we want to know the middle number. How many observations do we have? We have a total of 36 observations. The median is also sometimes referred to as Q2. The formula for the median and Q2 are essentially the same. So for ME, we're going to say ME is equals to, or ME plus C in bracket n divided by 2 minus the cumulative frequency that is before divided by the frequency of the median interval. Okay, let me explain this. like I explained before, this is the lower limit of the median interval. This is the class width. This is the number of observations. This is a cumulative frequency of the class that would be before what we would call the median. So we need to substitute this. How do we go about it? We need to find the middle ground. So we say 36. Take your 36, more like take your n divided by 2. 36 divided by 2 would give us 18. So our median would be where there is the 18th observation. So it's not in the 10, because the 10 would encompass now 11, 12, 13, 14, 15, 16, 17, 18. 18 will be here. So essentially now we mark this as our median interval. This whole thing is our median interval. So that's the use of the table now. So we now need to substitute. What is the lower limit of this interval? The lower limit would be 20. So this would be equals to 20 plus, what is our class width? It is 10. And what is your n? Your n is 36. 36 divided by 2 minus the cumulative frequency of the class. We picked this interval. This is the cumulative frequency, so we need the one that is before. So the one that is before is this one. So we're going to say take away 10. And we divide by the frequency of the median interval. The frequency of the median interval, FME here, that's the frequency of the median interval. So we're going to divide this by 9. So this is essentially going to give us 20 plus, in brackets, 10 multiplied by an 8 divided by a 9. That would be equals to 28.88. 28.8. Okay, to the nearest we can just gonna say 28.89 minutes. So that's the B part. So we've done the mean, the median. What about the median? Know that the median is also equals to your Q2. So I'm just gonna wrap this and we are going to do the other part. Right, the next part of the question says calculate the mode. So I'm just going to write mode here. Mode, this is C. Your mode abbreviated MO. What is the mode? The mode is the class or the number with the highest frequency. So what we should do is to go to the highest frequency and we check, okay, the highest frequency is this one, yeah. This is the one with the highest frequency. Is higher than any other class. So our answer should be within here. So we need to be able to write the formula and be able to substitute and work out the answer. So the mode would be equals to, or more, plus, we're going to do the calculation for the mode now. That's C bracket FM minus FM 1 over 2 FM minus FM minus FM. This is plus 1, subscript of 1. So we've got the formula. What we need to do is to substitute. How do we substitute? Before we substitute, let's know this is the lower limit of the modal interval. This is the class width, the gap between any of theirs. And then this is the frequency of the modal interval, the frequency which we found to be 9. And then this is the frequency of the class before. So let me just label these things. This is FM minus 1. This is FM, and this is FM plus 1. So we know where they lie, so we can actually do our substitution. So what we're going to do is to now say the lower limit is 20. So 20 plus C is our 10 in brackets 9 minus the one before, which is a 7, divided by 2 multiplied by the 9, minus the one before is a 7, and the one after we are still taking away, and so this is equals to, so you're going to do your calculation, that's a 2 times 10 is a 20, 20 divided by, in brackets, 18 minus 7 minus 8, close the bracket, that will be 6.23, and we add it to the 20, so this is going to be 26.67 to the nearest, that's in minutes. So you can check your answer. We say that it should lie within here. Does it encompass the 26? Yes, it does. So your answer is within the range. So that's how you calculate your mode. Number D. So D, interquartile range. The formula would be your Q3 minus your Q1. So essentially we need to be able to calculate our Q3 and calculate our Q1. Q3, the formula would be essentially the one for the mode, but now it's going to be divided by 4, and we use stuff that relate to 4. So this is going to be O Q3, just like how we wrote for the mode, and then we're going to plus, right, the C in brackets, this is Q3, so this is 3 multiplied by N over 4. Right, minus the cumulative frequency of the class that is before that, and we're going to divide this by the frequency of the Q3 interval. So let's look at this. How are we going to get these figures? We need quartile 3. Remember, quartiles, we are simply saying our data is divided into a block, and we have one block, this is Q1, and this is the Q2, you see it's by the middle, that's why we call it the median, and then this is your Q3. So we want to calculate Q3, so it needs to be lower here. So what you do is you take your numbers, right, 36, multiply it here by 3, and then divide it by 4. That will give you the position where it's supposed to be. So we take our calculator, we say 3 multiplied by 36, and then we divide this by 4. So it is by the 27th observation. Wow, just went straight ahead there. So this is our Q3 interval. If it was 28, then we would fall into here, but it's falling into this category. So we need to substitute. How do we substitute? We need to say the lower limit. We say it is on here. So this is our Q3. This whole interval is our Q3. Calculate by substituting. So the lower limit there is going to be 30 plus the C is a 10. And then we're going to say 3 multiplied by a 36 over the 4 minus what is the cumulative frequency of the class before. It's going to be this one, 19. Right, and then we're going to divide this by the frequency of that interval. The frequency of that interval is going to be 8. So this is going to be equals to, in terms of calculating, we say the 27, take away the 19, multiply by 10, divided by 8, so that's a 10 essentially, plus the 30, that will give us a 40. It's right at the end, and it's the very last figure, and it's within the range, so the answer is fine. So that's your Q3. Let me just try to squeeze the Q1 here. Q1 would be essentially also equals to O Q1 plus C. Instead of saying 3 now, we're gonna say just 1n, or n over 4, minus the cumulative frequency of the class before the Q3, and this is all divided by the frequency of the Q1 interval. So let's substitute. First we must find what is our Q1. To get the Q1, we're saying n divided by 4. N is 36, so we're going to say 36 divided by 36 divided by 4, which gives us a 9. So the 9 is within here. So this becomes our Q1 interval. This becomes our Q1 interval. So what we're going to do is to say this is equals to, this is our Q1. So we need the lower limit. The lower limit is going to be 10. So this is 10 plus C is 10. What is N? 36 divided by what? By 4 minus the cumulative frequency of the class before. So that's going to be 3. And then this is divided by the frequency of the cumulative frequency of that interval, which is 7. So this is equals to a 9 minus a 3 multiplied by a 10 divided by a 7 plus a 10. That would be 18.57. So is it falling within here? Yes, it is less than 20. So essentially we can now substitute into what we called our Q3. We're going to say, I wish I had space here, IQR is equals to your Q3, which is 40, take away the 18.57, so this is equals to 21.43 minutes. That's the interquartile range. If you're asked for the range, it's always the maximum minus the minimum, but when it comes to quartiles, we just have 3 quartiles, so it's going to be Q3 minus Q1. So that's how you're going to calculate. We need to move on to the standard deviation. At the standard deviation, what do we mean by standard deviation? Standard deviation is the move from the mean. So we're going to need the mean to calculate this. The formula for the standard deviation will be given by, what we should know is that the standard deviation and the variance are kind of like two things which are almost the same, but the other one is the square root of the other. So the standard deviation is equals to the square root of the variance. Alright, so when we calculate the standard deviation, if we are given the formula for the variance, then we need to get the square root of this. So this is equals to the square root of summation of fx squared minus x bar multiplied by n squared divided by n minus 1 divided by n minus 1. So this is equals to, you remember our figures, we calculated these figures, so you should be able to go back to your table, because that was the reason why we calculated this. This is 39,300 minus 36 was our observations, and our average was 29.72. So we're going to square this, and then we divide by 36 minus 1, that's 35. So this is equals to, that's our standard deviation. So that's standard deviation, and it means that we are moving about 14.64 minutes away from the average of 29.72. The other requirement is to calculate the coefficient of variation. So F, our CV, normally abbreviated CV. So this is CV. Your CV is equals to Sx over x bar multiplied by 100. So the standard deviation is 14.64 divided by the mean. We already have the mean here, 29.72, and then this multiplied by 100. We do the calculation, 14.64 divided by 29.72, that will give us 0.42, 0.942, say 6. What does this mean? This is a very high variability, meaning to say that if you were doing investments, you can't really trust to always have a solid return. It can actually fluctuate. So that's the essence of the standard deviation. Question number G says calculate the coefficient of skewness. Calculate the coefficient of skewness, SKP. We can use what we call the Pearson's coefficient of skewness. There are other different formulas that are still applicable depending on what you were told to use. So this 3, take away the x bar minus ME over the SX, the standard deviation. So how are we going to substitute? This is going to be equals to 3 multiplied by our mean was 29.72 minus the median 9. And then we divide by the standard deviation, which is 14.64. So this is equals to 3 multiplied by 29.72 minus 28.89, or divided by 14.64. That's going to be a 0. This is actually positive, plus 0.1700. So this is plus 0.17. This is a positive standard, positive skewness, meaning to say that the shape that we actually have here is one that goes like so. This is a positive graph. If we were to redraw the histogram, it would be positive, slightly positive. That's a positively skewed data when we look at normal distribution. So that was the calculations that we needed to understand and know. These are basic calculations. There are more calculations to follow. So click like, share the video, subscribe for more videos to come. Otherwise, for now, that's it.